In this video, we're going to learn about a topic called iteration. Imagine we were trying to solve this equation here. This equation is known as a cubic equation because it has an x to the power 3 as the highest power. So it's not a quadratic equation, so we can't use the quadratic formula for instance. Fortunately, iteration is a method for solving equations that will help us. A typical start to an iteration question might look something like this. Part A. Show that a solution to the equation lies between x equals 1 and x equals 2. So the question's actually told us that one of the solutions is between 1 and 2. We're asked to show that this is the case though. To do this, all we do is take the equation and substitute in values x equals 1 and x equals 2. So if we substitute in 1, we'd get 1 cubed minus 2 times 1 minus 3, which comes out as negative 4. If we substitute in 2, we get 2 cubed minus 2 times 2 minus 3, which gives us 1. At this point, we can observe what we call a change of sign. It's a change of sign because we've gone from negative to positive. It would also be a change of sign if it went from positive to negative. The reason this shows a solution is easier to see on a graph. Imagine we were sketching this graph, and we were plotting the points for 1 and 2. When we plotted 1, it was at negative 4. When we plotted 2, it was at positive 1. So if we were to draw the graph of this, we'd somehow connect up these 2 points. Now it probably wouldn't be a straight line, but somewhere between these 2 points it must cross over the x-axis. When it crosses the x-axis, we know that would be a solution to the equation. So a solution must be between x equals 1 and x equals 2. So what we can say here is that the change of sign shows there must be a solution between the values x equals 1 and x equals 2. You should note that this method only works when the equation is equal to 0. If the equation isn't already equal to 0, just rearrange it so that you get 0 on the right hand side. Then if you notice a change of sign, you know there's a solution between those two x values. Now that we know a solution lies between 1 and 2, we can use iteration to find this solution really accurately. The first thing we're going to do is imagine we were asked to make this x the subject. So we're going to rearrange it so that x is on the left hand side. To begin, we're going to add 2x and 3 to both sides. If we add this to the left hand side, it cancels out the negative 2x and negative 3. So we're just left with x cubed. On the right hand side, 0 add 2x add 3 is 2x add 3. The next thing to try and do is remove the cubed. The inverse of cubed is cube root, so we'll cube root both sides. If we cube root the left, we just get x. And if we cube root the right, we get the cube root of 2x plus 3. This might seem like quite an unusual approach, but it will help us out. The next thing to do is take the x on the left hand side and write it with a subscript n plus 1. And any x's on the right hand side become x with a subscript n. This is now known as an iterative formula. Often the iterative formula is given to you in the question, but you may be asked to show that it does work, like I have done in this question. The follow-up question could look something like this. The iterative formula can be used to solve the equation. Part B, given that x0 equals 2, calculate the values of x1, x2 and x3. Now, to understand how to do this, you need to understand what an iterative formula is. xm plus 1 here refers to the next term of a sequence of terms, whereas xn refers to the current term we're on. If, for example, we started with our current term as x0, and we substituted in that number, and then worked it out, it would tell you what x1 is. You could then take that term and substitute it in, work it out, and you'd get x2. You could then take that term, substitute it in, work it out, and you'd get x3. And you can carry on this iterative process. x3 gives you x4, and so on. So all an iterative formula tells you is the formula you need to use to work out the next term. And that's what we're going to do now. In the question, we were told that x0 equals 2. This is known as our initial term. We need to calculate the next 3 terms. So we need to calculate x1 first. To calculate x1, we're going to write out the formula cube root of 2 times x0 plus 3. And we're using x0 because that's the term we currently have. We already know what x0 is though. x0 is 2. So if we substitute x0 for 2, we can calculate this. You can now type this into your calculator and you'll get this number here. In an iteration question, you're probably going to need to write your whole calculator display down. We can now use this value for x1 to get the next value for x2. So imagine x1 is our current term. x2 is our next term. So we're going to do the cube root of 2 times our current term, which is x1, and then add 3. So we substitute x1 for this long number here, and then calculate it. It's important at this point that you don't round the long number on your calculator. You want to type in the whole number. Or even better, use the answer button on your calculator. So x2 would come out as this number. We can then imagine that x2 is our current term and then calculate x3. So x3 would be the cube root of 2 times our current term, which is x2, add 3. We can then substitute the x2 for our most recent number, which is this one, and then type this into a calculator, again being sure to use the whole number. So x3 would come out as this. We've now completed the question because we found the values x1, x2 and x3. Part C asks us to solve the equation, giving our answer to 5 decimal places. If we think back, this was our original plan with the question. We wanted to solve the equation. So far, we were given the x0 value of 2, and we calculated x1, x2 and x3. Each of these successive iterations is an approximation to the solution. The further you go, the better the answer. So to find the solution, we need to keep this going. We can find x4, x5, and so on. Fortunately, this is made a lot easier using a calculator. We can calculate iterations really quickly using a calculator. To do this, I'm going to press 2 and then equals, because 2 was the initial value of x0 that was given to us in the question. The effect of this is this number 2 here is stored in the calculator's memory. It was the most recent number it calculated. Now we'll go ahead and do the iterations. So we need to do the cube root because it started with a cube root. That's on shift, so shift, cube root. Then it was 2 times the previous answer. So I know the previous answer, x0, that was 2, so I could just press another 2 at this point. Or I could press the answer button, because that's the number the calculator most recently calculated. Then it was plus 3, and then press equals. And you can see the number on screen matches the one that we calculated. Now we need to get x2, and you could do it by repeating all of those steps. But the calculation you need is already on the screen. If we simply press the equals button now, the calculator will take the most recent answer, the one displayed on screen, and put it into this formula here. So if we press equals, you'll see we get the next answer, which is x2. And then we press equals, x3 equals x4, x5, x6, x7, x8, x9, and so on. In fact, you can go even further than this. If you continue to press equals, you'll see the number gets closer and closer to the exact answer, and eventually, when you get to this point here, no matter what you do, if you keep pressing equals, the number has settled. So this is the number we need to round to get our final answer. The question said 5 decimal places, so 1, 2, 3, 4, 5. So the 5th decimal point here is an 8, but it's got a 9 after it, so we'll need to round up. So the final answer rounded to 5 decimal places is 1.89329. So we've managed to find one of the solutions to this equation. A common follow-up question is to ask you just how accurate your solution is. It might read something like this. Part D. By substituting your answer from part C into x cubed minus 2x minus 3, comment on the accuracy of your solution to the equation x cubed minus 2x minus 3 equals 0. All we need to do here is write out the equation again, but instead of x, we're going to write our solution, 1.89329. 1.89329 cubed minus 2 lots of 1.89329 minus 3. Now if you type this into a calculator, you'll get 0.00000703525. So a very, very small number. So we could say that this is very close to 0, so our solution is a good estimate for the real solution.